Hello, I'm Mr. Gale, and I'm going to look at some normal distribution questions in a core math style, and I'm going to just do some worked examples for you. So you might want to pause this and actually read the questions. Okay, so the thing I want to point out here is the bit where it says the contents of jars of honey follow a normal distribution. If the weight's x, then x is distributed normally 400, 60. So it's important here that we know that that means that the mean is 400, with mu being the mean, and that the second bit is telling us the variance. So the variance is 64. And that's not usually what we really want. We want the standard deviation. So the standard deviation is the square root of the variance. So square root of 64 in this case, and it's going to be 8. So mean of 400 and standard deviation of 8. So that's what we're getting from there. Okay, so I'm going to go through each of these questions in turn. Part A says, find the probability that the weight of honey in a jar is more than 406 grams. And you'll see I've got a diagram already set up. Things that are always the case are that the mean is directly in the middle. So I'm just going to pop on 400 there. And I'm looking for more than 406. So I don't know exactly where to put that, but it's just a diagram. It's not meant to be accurate. So 406. And then I'm going to try and use a system where I'm going to shade in the bit that I want in green. Green is the bit I want. So more than 406 means I'm looking for this part here. Probability is linked to the area. So if I can find the area of this section, that'll do the job for me. There are tables to help with this. This is an example of the table. It's given to you in the exam. You obviously don't have to memorize this. And look how this diagram is set up. The shaded part is to the left of the line, and it's talking about a Z here. So I need to do that first. I need to find out what my Z score is. Gone the wrong way there. Okay, so Z is how many standard deviations above the mean are you looking? So let me get the blue pen again. So Z is how many standard deviations above the mean. And the way to do that is the value you're interested in minus the mean divided by the standard deviation, which we know is 8. And then you can do that on a calculator, but 6 over 8 is 6/8, 3/4, and that's 0.75. Okay, so my Z score, we say, is 0.75. I'm looking for 0.75 standard deviations above the mean. And the table will give me this part here. So the table always gives you the bit to the left-hand side of the Z score over here. So that red bit is what I'll get from the table. So I'm just going to go and look that up. 0.75 is what I'm looking for. And the way these tables work are you get the first decimal place and, well, the integer part and the first decimal place on the left-hand side, or it's over here as well if that's easier. So I want the 0.7, and my second decimal place should be a 5. So that's across the top. 0.05 with the 0.7 together makes 0.75. So this value here is the one I'm looking at, 0.77337. If you're going to use these tables, I recommend using 2 rulers. So 0.77337. Okay, so you want to be just a tiny bit careful. I don't want to put 0.75 equals 0.77337 because they're not the same thing. That's not true. You can say, you could write here, I looked 0.75 up in the table and got this. But there's a cool symbol for that. It's this Greek letter. It's a capital phi. It looks like a capital I and a capital O sort of on top of each other. So this is code for I've looked up 0.75 in the table, and that came out as that. You don't have to use this, it's not expected, but it's a nice shortcut, so why not? So looking that up in the table, 0.77337, but that's the red part. That's the red part here. And that's not the bit I want the green bit. So the other useful thing is that the full area under this curve comes to a total of 1. So the green part that I want is done by doing 1 take off the red part. So I might write that out. I might say that the probability that x is greater than 406 is 1 minus 0.77337. That's the red part. And then I can just do that. You can use calculator if you like, but it's going to be 0.22663. And that is the answer. That's the bit I want. That's the green part. So that's correct. If you did want to round it, you can do, but I wouldn't round it to any more than 3 decimal places. So I wouldn't go too short. Like I don't want to put that's 0.2. You could put 0.227 if you wanted to, but I wouldn't go any more than that. And there's no harm in leaving it like that unless you're told otherwise. Okay, so that's question A. Question B, find the probability that the weight of the honey is between 390 and 410 grams. So this one is more difficult, but we're going to start off the same way again, put the mean right in the middle, 400. I don't know where to put these exactly, but I'm going to go 390 there. And I am going to notice that 390 is 10 below 400 and 410 is 10 above. So this is symmetrical, which is nice. Makes things a bit easier for us. So I want the bit between those. Just going to move that across a little bit. So the bit between those is the green bit. That's what I want. And now we've got to think about how we're going to do that. So the table, if I did it and found the z-score for 410, the table would give me the part to the left of this line. So all of that green bit, but also this little tail over here, which I don't really want. So I might need to think of a different way. There's probably 2 different ways of doing this, I think. I could find the bit to the left of this line, and then I could work out that little tail there, and I could take that off. That's certainly an option. I'm probably going to find this tail part at the top end, and then I know that it's the same as that area there because of the symmetry. So then I'll take those 2 bits off of one whole one. Okay, so I'm going to go down for that route. You'll see I've already prepared for this. I've got, I think, a second diagram down here. So this one is for 410, 400 there, and 410 here. And for the sake of this part, I want to know this little bit here. So I'm not going to do that green because the green is the bit that I want. So I'm just going to use blue. Blue to get that little bit to help me work out the green part up here. So that blue bit there. So I need to know how many standard deviations above the mean I am. So Z is the value I'm interested in minus the mean over the standard deviation. That's 10 over 8, which is 1.25. So I'm going to look that value up in the table and see what I get. So 1.25 is what I'm looking at. So that means I need to go down to 1.2, which is there. And 1.2, the last bit was 5, so it happens to be in the middle again. 0.89435. 89435. And okay, so that is this red part here. So the table always gives you the part to the left-hand side. So this big part here, I want the blue bit, and the blue bit is 1 minus that red part. So this part here is 1 minus 0.89435. So it's 10565 for that. And I know that that blue part there is equivalent to this blue part here. I'm quite tempted to do my working out up here, but that would be very, very confusing because I've actually started here. So if I then go back up and start working things out, it's going to be really hard for anybody else to follow. So although my diagram's up there, I'm just going to do my work down below. So that blue part there is this blue part here, which we've just discovered is 0.10565. And by symmetry, because these are the same distance apart, this one's also going to be 0.10565. And so finally, I can actually do the last step, which is, so the bit that I really want, the green bit, the probability that x is between 390 and 410 is 1 minus 0.10565, taking off like the left-hand end, but also take off the right-hand end as well. And I think I want a calculator for that, super quick. Won't take long. So one, nearly there, 0.10565. That's 0.7887 apparently. So 0. And that's that done. That's the green bit in that original one. So that's the chance, the probability, 0.7887. Now, we haven't been asked to, but if you did get asked to give us a percentage, then you just times by 100, it'd be 78.87%. Okay, on to question C. So this one here, this is about as awkward as it gets for these. Between 380 and 425. So the mean's still in the middle, that never changes. 400, the mean's in the middle. 380 is over here somewhere. That's 20 less than the mean, and this is 25 above the mean, so it's not symmetrical anymore, which makes it a little bit worse. So, interested in the bits between those. That's the part I want. So, well, let's deal with the 425 first. There's different ways to think about doing this. So an option could be, for example, but a bit like last time, I could get this yellow section here, and I could get this, let's go blue section here, and I could take those off of 1, and that would do the job for me. I'm quite tempted to go down that route. That's certainly an option. Another option would be to use the 425 and get all of this section here. I could do that, and then take off that blue section, which now looks green, that section there. Okay, I'm going to go for that. I want to find that whole yellow highlighted bit, and then I'm going to take off this little section here. I'm going to put, let's put a letter in there just for fun. Let's put an A in there. So the yellow bit, take off A. All right, well, let's do the 425 first. I need to know the Z-score. Because I'm going to have two different Z ones, I'm going to have a Z here and a Z over there. I'm going to call them different things just so we don't get horribly confused. I'm going to call that Z2 and that Z1 because I'm doing this one first. That's why I've called it Z1. It doesn't matter, but this is the first one, so Z1. Z1 is 425 minus 420. That's not 420, sorry, that's a mistake. The mean is 400 over the standard deviation of 8. That is 25 over 8, which I am going to just double check on the calculator. 3.125, okay. Okay, so that gives us a little bit of a problem. The tables only do two decimal places. First decimal place here and second decimal place there. So I can't look up 3.125 on here. So I am going to round that. I'm going to leave that like that, and then I'm going to look that up. So let's look up. That's not the best one of those symbols I've ever drawn. 3.13 in the table. Okay, so I'm going to have to go down quite a long way. 3.13 is going to be very near the bottom. Only just fits on, in fact. Well, it's that bottom row, isn't it? See if we can get that line to move. Sorry about that, don't know what's going on there. Right, 3.13 is the bottom line. I'm going to actually put a line above this bottom line here. 3.13, this will be 3.130, 3.131, 132, 133 is that one. So 0.99913, almost everything is less than 425. 0.99913. Okay, so 0.99913. And that's the area of the bit that I highlighted in yellow. That's everything to the left of that line. Okay, so I need to think about this one over here now. This is a little bit worse because it's below the mean. 400. And I want the value 380. I'm going to figure out my z-score for that. So 380, I'm calling that my second z-score, Z2. It's worth bearing in mind right now, this is very, very much at the top end of difficulty for the core maths course. So if you're sticking with it, you're doing very well. This is 380 minus 400 all over 8. That's minus 20 over 8. And 20 divided by 8, I think that's 2.5. Yeah, so we got minus sorry, there's a minus in there. Minus 2.5. Now, that presents us with a different problem because that's not in the table. We don't have minus numbers in the table. We've got 2.5. 2.5. Really, it's 2.50 is the last decimal place. That's that one there. So we might come back to that in a second, but we need to think what we're doing before we just start reading numbers out. So what we've got is that this z-score is 2.5 standard deviations below the mean. And we don't have a table to deal with that, but we do have the fact that this whole thing is symmetrical. So instead, I'm going to go with, let's think about over this side. I'm actually going to get rid of that, just so we don't get confused. Let's go over this side. And what about for 2.5 standard deviations above the mean? Because it's going to be symmetrical. I want the bit down here, 2.5 standard deviations below the mean. But if I look up this end instead, then I can just use symmetry. So if I look that up in the table, it's going to give me this red part here. Okay, let's do that. Didn't mean to press that either. Let's look up 2.5. So I can't look up minus 2.5, but I can look up 2.5. So 2.5, did it leave it there? Yeah, 0.99379. 99379. Okay, and that's the red bit, which isn't the bit I want. Just move up a bit. I want this little bit that I labelled A here, and that is the same size as this little bit over here, which perhaps I can call that A as well. So this bit in here is called A, and that is 1 minus this red section. So I appreciate it's pretty complicated, but choosing to put a letter in there just makes it a tiny bit easier. I can now say A is 1 minus 0.99379. Nines are not coming out very well. 9. I'll see if I can work that out. That is 0.00621. We are very nearly there now. So, the bit that I originally labelled with green diagonal lines is the yellow highlighted section, take off A. So the yellow highlighted section was 0.99, I've forgotten it, 31 something? 913. 913. Take off the bit labelled A, which is 0.00621. I think it might be worth using a calculator for that. And then finally, get my final answer of, so the probability (380 and 425). So the probability that x is between 380 and 425 is 0.99292. So that one is quite a lot of work. You might be wondering if there's a shortcut. And if you've got the fancy calculator, the Casio FX991 class Wiz, then yeah, there is a huge shortcut where it does pretty much all of this for you. But that's not what this video is for. Okay, 2 more to go. Right, this is a much nicer question. Find the probability that the weight of the honey in the jar is more than 400 grams. Well, 400's here. So I can put my line in. Let's imagine that's a straight line. Vertical line. And the bit I want is to the right-hand side of that, the bit that's more than that. And then we can do a super sneaky trick here. Well, not trick. We don't need to work anything out here. There's a useful thing in that for this one, the mean is 400, obviously. And that's actually the most common result, which is why it's got the peak there. So that's also the mode. But importantly for us, that's also the median. It's symmetrical and the peak is bang in the middle. So it's the mean and the mode and the median are all equal here. Now you might not know this, but that doesn't always happen with everything, but it does with a normal distribution. So this question is, find the probability that the weight of honey in the jar is more than the mean or more than the median. Well, the median's bang in the middle. So more than that is just 50%. Don't need to do any more work than that. Half of the things are more than the median. So that's the quickest question you could ask. would probably be worth 1 mark. All right, and then here is a question where we're asked to justify something. The label on the jar states that the minimum weight of honey in the jar is 380 grams. Can that be justified? Well, let's label some things up again. 380 there, over here somewhere, 380 roughly there, that'll do. I want to find out, well, how many things are less than that then? Are any jars likely to be less than 380? So we're going to have to make a judgment call later on, but let's find the probability that a jar is less than 380. Well, this is one of those times where the z-score, let's just use green, just so I'm consistent. Green is that bit there. That's the bit I want. So the z-score is going to be negative because it's below the mean. So z is 380 minus 400 over standard deviation. So minus 20 over 8 is minus 2.5. I remember that from a couple of questions back. Minus 2.5. So I can't look up that, but what I can do instead is look up the mirror image, the z-score of 2.5 over here. So I'm going to do that. I'm going to look up 0.5, bonus points if you can remember it. I mean, I definitely can't. Too far. So 2.5. It's 2.5 is 0, really. Oh. Wait for this to respond. 2.5, a little bit further. Nearly there. There we go. It's that one there. 0.99379. So 2.5 is 0. So 0.99379. 0.99379. So that's me imagining looking up the value of 2.5, or looking up, and that's the bit to the left of there. That's not the bit I want. I want the bit that's to the right of that value, which would be symmetrical with this one. So 1 minus 0.99379. So probability of a jar being less than 380 is the answer to that, which is 0.00621. 0.00621. So for this one, I might want to change that to a percentage, timesing by 100. So 0.621%. Less than a 1% chance that a jar would be less than 380. So we haven't quite answered the question, because the question was, the label on the jar states that the minimum weight of honey in the jar is 380. Can this claim be justified? Now, there isn't an easy answer to that. You get to make a judgment call. So you could legitimately say, well, 0.621 isn't 0. So there are some jars that are less than 380, so no, the claim isn't justified. That would be a reasonable answer. You might also go down the route of saying, well, although there are some jars that are less than 380, it's a very, very small percentage. It's only about 0.5%. I think that within the realms of jars of honey, it's reasonable to say that jars aren't less than 380. And because it's a justify thing, you can probably argue both sides of those coin and get marks for it. It's not a clear-cut answer, so you have to be allowed to use your justification. Right, well done for listening. That is a lot to take in.